Zombie apocalypse.
Okay, before we proceed with the calculation of crack and uncrack stages of pre-stress concrete beam, let us try to analyze first how do we assess the pre-stressing seal stresses, okay, using the provisions of Nscp 2015. So get ready to be neurorized. So how do we calculate if the pre-stressing force is most likely not to be given? So the formula for that is P is equal to A sub PS quantity F sub PS. So meaning APS is the steel area of that particular tendon in question, while the F sub PS is the steel stress in the as found in the material. So let us analyze on each part. Now, to analyze F sub PS, so ito muna yung kailangan natin ma-understand ng mga code. For FPS, ito muna, okay? In 420.3.2.1, so meron po tayong tinatawag na modulus of elasticity E sub P. Okay, for pre-stressing reinforcement shall be determined from test or as reported by the manufacturer. Usually kasi kapag ganitong case naman, we are using E sub P. Usually sa ordinary concrete, we are using 200,000 megapascal in the average. But for pre-stressing, we are usually in the value we are using the value of 197 gigapascal. Okay. So usually ito yung ating standard value for that. While for the tensile strength, F sub PU shall be based on a table that I'll present later. Now, in a more detailed calculation, just like in the prescription of 420.3.2.3.1, so here is the full setup. Okay. And with banded pre-stress reinforcement, default pre-stress reinforcement in the tension zone and FPS should be more than or equal to half of the F sub PU. Okay? So, yung gamma P is in a table. Pero ito yung kanyang mga kondisyones. So, if compression reinforcement is considered for a calculation of F sub PS under that particular equation, A and B shall be satisfied. No? Ito muna yung kanyang application. Kondisyones bago gamitin. Now, assuming that there is compression bar. Okay? If D prime exceeds the 0.15 of the depth of the effective depth, okay, or rather the effective depth of the pre-stress condition, dP, is 0.15 dP, the compression reinforcement shall be neglected in equation 420.3.2.3.1, meaning yung rho prime, just like your RCD discusses, no, rho prime is AS prime over BWD, so therefore that should be eliminated in the equation, so making it just only rho. Now, what's the other code? Also, if compression reinforcement is included, so if that is that is to be integrated inside the equation, so the term as stated here shall not be taken less than 0.17, meaning that particular equation should be more than 0.17. Okay? Kasi sabi dito, shall not be taken less than, so more than or equal. Okay? And the values of gamma P for such equation should conform with the following. Pero our Nscp 2015 is not stating of what are these particular three values all about. No, let me try to state what are those constant all about. So for the 0.8, it suggests that is for under deformed bars kasi pwede nating gamitin, okay, yung ating deformed bar. So you have to use the ratio of FPY over FPU as 0.8. Okay? So ano naman kaya si 0.85? So si 0.85 is under stress relief. Okay? Stress relief. Okay? It may be wire and strands. Okay? Wire and strands. Also, can be applied in a plane bars, okay? Pwede siyang gamitin for plane. So, if those are the condition, then use 0.85 as a ratio of FPY over FPU. While the remaining one, the 0.9, okay, of FPY, F.9 as a ratio of FPY over FPU, so that resembles low relaxation. Yan. Low relaxation wire and strands. Wires and strands. Okay. So just in case the conditions are not given, if that is stress relief, low relaxation. So I'll try to discuss that in the future on how do we assess if that is under low relaxation, under stress relief, or under deformed bars. Okay. And if you know already the value of that particular ratio, then you would use the equivalent gamma sub P relation. Okay. So here is now the calculation of the F sub PS. So using this table, you would use if the given states that at the jacking end, or usually the default condition, so you will choose the least among the three. Okay. However, if you want to calculate FPY, so dyan, napapasok yung importance ng kaninang relation na sinabi ko, if low relaxation, stress relief, and or deformed bars yung gagamitin as a function of F sub PU. Okay? But if the given statement suggests at post-tensioning, that's the key term, the anchorage, the vice and couplers, okay, that means immediately after tendon anchorage, so use 0.7 of FPU. So, ito po yung sources sa FPU natin. Si wire, usually, ito po yung mga stress relief and low relaxation type natin. Usually, ito yung mga titawag nating grade 250. Okay? While usually, pagka strand naman, na stress relief and low relaxation naman, grade 270 yung ginagamit, which is 1860. And high strength bar, usually, it can be under deformed. Okay? So ito naman yung para sa assessment ng ating steel area kasi APS should be the total number of tendons or wires multiplied by each individual areas. So depende sa type of strand or wire na gagamitin tsaka yung grade. So usually on typical yung common 7 wire strand but of different grades if you notice, grade 250 tsaka si grade 270 as explained earlier. So may mga dimension in inches and then their equivalent in meters. Okay? In meters yan. So, ito, mga inches square. So, you can convert in terms of square millimeter na lang. Before, in the Nscp 2010, naka-indicate in terms of area na millimeter squared. But here, I think, easy naman to convert. Kaya that's why you can do the job for conversion in terms of square millimeter. Note that the area does not apply pi d squared over 4 kasi diameter is just 0.25. No, it is not of circular section. So, there should be a true area, no? And these are the others of prestressing wire for bars type, okay, as stated. Yan, kompleto siya, no? Okay, so that's the information that I can provide it to you today. So, by applying P is equal to APS FPS. So, thanks for viewing. And as a tradition, you have been neurorized and see you in our next video lecture.